Thanks, Jeff. I appreciate it. I want to thank you and Crescent for putting this on, and the opportunity to bring some timely information out to the marketplace. And as everybody knows, this is the time of year where things start heating up, and we were kind of chatting even before this that in some places, out of Ohio next to the plant, we end up going right from winter into summer, and there's not much of a kind of leadway into or segue in through spring. So it's kind of critical to start talking about climate control and understanding how important its role is in both control and switchgear applications, and just to keep everybody's plan up and running, and to get out ahead of the curve, right? And to recognize the opportunities there before you experience a problem, because when you experience those problems, it's significant cost and loss of revenue from the downtime, not just the failure of the control. So what I'm going to do here is share with you our latest air conditioner series called the Blue E Plus air conditioner, and then also remote monitoring and management device that we have that ties some of our other climate control devices under an IP address. So you have the ability to remotely monitor and manage these devices, as well as receive instant alerts to your phone or to an email setup there. So, this is kind of common sense, but when we're looking at what causes electronics, this is part of the problem that we face, and we start seeing this increasing as we go into the summer. What are the reasons that these electronics crash, right? What causes failures? And you can see overwhelmingly here that it's heat related. You get into things like vibration, humidity, which is again is just combination of moisture in the air and air temperatures, and then dust. Relative humidity in the cabinet can also be too dry. You can also have problems with static electricity, which is also very damaging to electronics. And so it's a unique balance of what we have to do inside of an enclosure with climate control. And so these are things that we have to try to prevent. And and it's not just heat, but there's cooling on the other end of it too, because just like things have an upper temperature range before they start to act erratically or fail, you have the exact same thing at the bottom end where it can be too cool, and we need to manage that as well. So there's just kind of if it's just a physics equation, right? So you're just looking at a truism that with semiconductors and a lot of control systems, that for every 10 degrees C or 18 degrees Fahrenheit above the max operating temperature of electronic component, the service life of that device is halved, right? It's cut by 50%. And you see here the chart with the blue line, and the blue line starts out at 100% with about 0K, which is your Kelvin and your Celsius scales are intervals. So they're considered the same for this kind of application. And so you see that as you approach, almost 20 degrees above the max operating temperature rated for a device, it drops off by half. And then the red dotted line is the increased failure rate. And, they don't heal, right? So once you damage an electronic device, it's damaged for the life of the device. And every time you kind of abuse it, if you will, it suffers more loss. And eventually you'll lose the service life of the component, which means you're replacing it more often, and then the resulting downtime. So, this is certainly a problem. And, for maintenance or people that are, paying attention to the systems that are running the machines or their processes and generating revenue, you're not out there on the floor every day, monitoring this maybe, or looking at temperatures, nor maybe do you understand, maybe there's something that's starting to fail that's causing a temperature rise in the cabinet. And guess when you experience it? When it fails and the line's down, you have an overheating situation. So wouldn't it be nice if there were a way to, get an instant notification, or to set up thresholds where you could be alerted, and then maybe you've got the ability to notice trends. Okay, so we have this device called the Iot Interface, or the IoT module, that allows us to do exactly that. It gives us remote monitoring and management. And I'll show you a little bit of this right at the end of this presentation. But this is just the facts, all right? This is just stuff that we can't change. This is the physics of heat and what happens with electronics. So if we look at this from another, a problem, and there's many people that, when we pulled the industry, we said, okay, guys, as we're generating back 2011, 2012, as we're considering the design of the next generation air conditioner, what are your concerns? What are things that you would like to see as a customer end user? What kind of headaches can we help you solve? And so the top four here were, hey, bring us something that's energy efficient, right? So this was a global survey. And so you can understand that certain areas are a lot more energy conservative than others, and reducing carbon footprint and emissions and reducing CO2. Other things are just depends on who's using it, right? So you can get down into things that are maybe at the OEM level where something like multi-voltage would be important to them. So the top four, energy efficiency, and then the ease of mounting, right? Make it easy for me to put the air conditioner, for example, on the cabinet. Ease of handling it and the usage. And then again, I mentioned multi-voltage. And so what we came out with the Bluey Plus air conditioner, this next generation air conditioning unit that we have, is a patented technology that I'll talk about for the energy efficiency side, but ease of mounting or ease of handling, right? I want to read you something from, and I'm not going to give away the name of who this other manufacturer is for climate control, but I want to read you something that you can understand why people say make it easy for me, right? So here's some of the instructions from their manual. It says, place the air conditioner on a lift truck, insert a 1-inch approximately wooden block between the lift truck bottom and the air conditioner bottom, so the angle between the two and the panel is about 10 degrees. Adjust the truck so that the air conditioner hook is approximately 1 inch above the mounting plate. What in the world? I don't know about you, but it doesn't sound fun. No wonder these guys say, you know what, give me something that makes it easy. And so when we're doing our air conditioners, you have this large cutout. Let's take the device. It's got a handle that I'll show you. You simply just tip it into the bottom, tip it up. It clips into place just like that. So it's easy and it's safe. And then you go back in and put the permanent hardware in, you're done. So, if things are easier and they're quicker, that's also safer, which also leads, we don't need to even talk about the safety issues there, right? So anytime you can handle that, it's good stuff. So originally we looked at, who does this really appeal to? So machine builders, they're looking at things like flexible cooling range, because if you're using a restricted technology, you can only cool within a certain window, and it's a very narrow window. And typically you're wasting a lot of money when you're doing that. If you can open it up and be very flexible, then that gives you a broad range. And that also kind of increases your performance. Flexible air routing, parameterization tools really are things like, can I use a touchscreen on the air conditioner? Can I use my laptop maybe to set this up? Or guess what? Maybe I can use my cell phone and a near field communication app to record all the maintenance data or to pull information or to communicate with the air conditioner. I mean, how cool is that? So there's 3 different modalities there. For panel builders, it's things like, we ship all over the world. So something that is multi-voltage is pretty awesome for us, because then we don't need to consider what's my cooling capacity plus all the different voltages and make sure that I make that correct for every country that we might be doing business. So if that's simplified, that saves time and money. Cutouts. If I've got a bazillion sizes of air conditioners, you've got a bazillion cutouts. How would you make that easier? Well, maybe you just standardize on the cutout. And maybe the form factor of your air conditioner, regardless of capacity, is the same cutout. So that saves me time and money, because I just got one cutout. So one template, maybe one gauge or one device that I'm using. That's easy on my panel shop. And again, we talked about making it easy to mount and price for performance ratio, because just like anything, the cheaper you go, the less value it has in it. And everybody doesn't want cheap stuff. Everybody wants the best product for their money. And another way of saying that is price for performance ratio. End users, save me money on electricity. Save me money on what it costs for my cooling. Make it last long. Build in a quality product, things that's going to, survive maybe some harsh environments. Maybe it's indoors, maybe it's outdoors. Make my maintenance easy, make my exchange of components easy, cleaning and handling, maybe interchangeability or standardization of components. All these things are what, this thing is set up to solve for just a few users here, but certainly everybody that we can do business will benefit from this. And so really this title just says the world's first, meaning Rittal has combined heat pipe technology plus compressor-based cooling. And when I say compressor-based cooling, that's just what everybody else out there uses, right? Air conditioners are air conditioners. And then so what Rittal has done, and we've patented this, which means it's a protected product, which means we're protecting our market share and revenue with this. And then we're the only guys that have it, including the heat pipe technology. And so this is what drives some serious energy savings and energy efficiencies. And I think that probably on some information that you may have seen ahead of this, we talked about an average of 75% savings in things like energy and maintenance. And we're going to talk about what this air conditioner gives you, that we hit those numbers. And it's important to understand that that is on average, right? When people ask me a climate control question, and I've been at Rittal over 25 years, but when people ask me a climate control question, and I'm not just being snide, right? But the answer is really, it depends. Well, how often do I have to change filters? Well, it depends. Is it a filthy environment? Is it a clean environment? Is it oily? Well, am I going to see 75%, or can I get better than that? Or am I going to have worse than that? Well, it depends. It depends on the environment. It depends on your maintenance, and it depends on, other factors. So everything in climate control, because not only does it vary maybe season to season, but sometimes day to day, especially, we were just talking before this webinar that, it snowed 3 inches in Ohio last week, right? And so everything had bloomed, everything's green already, and now we get 3 inches of snow. So definitely our ambient temperatures and stuff inside and outside of the factory and around our equipment changed from day to day. And so, am I going to experience the same energy savings on Tuesday as I will on Wednesday? It's variable, right? So within this air conditioner, we talked about the two different cycles, heat pipe and compressor-based cooling. And so when we talked about active climatization, that's when we're engaging the compressor. When we're talking about passive, we're talking about the heat pipe technology. We'll kind of get into that a little bit, but that's where the real money savings are. And even though if we look at the range, not even the total range of this air conditioner, but we said we average around 75% energy efficiency. Again, it depends on temperature. So we can see temperatures as low as maybe at 59 degrees, 60 degrees ambient, that you could save over 86% in energy if it's running in total heat pipe mode. And then anytime you got to engage the compressor, that's kind of the energy vampire in all this, and that's the one that drives your energy costs. So maybe now we're well up, 95 over 100 degrees Fahrenheit, and you're engaging the compressor, and so that energy efficiency now is going to drop a little bit. So it might drop down into, somewhere in the neighborhood of 40-50% or something. So it just kind of varies on where your temperatures are and where the unit itself is located. So in this one, oh, I'm sorry, let me go back. Okay, so in this one, we're talking about active cooling. And if we look over here, we're going to see something like energy efficiency ratio. And we're seeing here at energy savings is 34% compared to our last generation, which was Blue E. So our Blue E air conditioner ran at about 45% efficiency. And now this one is even more efficient than that. And energy efficiency is the ratio of your cooling output to the energy input in watts. And so you want that to be a higher number. If you had like 100 watts of cooling and 100 watts of energy, that's a 1. If you're getting 200 watts of cooling and 100 watts of energy to supply the unit, now it's a 2. So the higher the number, the more efficient the air conditioner is running. So here, when it says we're using the compressor, you can see here that we've got a compressor usage at about 64%. Our fans are running. And by the way, Rittal uses EC fans, electrically commutated fans. So you're automatically saving 30% just on your electricity to run the fans relative to a standard fan. Because the difference between a standard fan and EC is 30% by design. Then we use nano coatings. So the condenser coils, the evaporator coils have, and we coat it blue so that you can see it, nano coating. And the idea is, think of Teflon on a frying pan. It doesn't allow dirt and dust to stick. Perfect analogy is, think about what we've all done in the last year, wearing masks, right? It restricts your breathing. So if I've got a mask on, it's a little more troublesome for me to breathe than without. And so if I'm breathing easier, I bet my pulse rate's lower and my, respiration is better. And then I stick a daggone mask on, and now my pulse probably goes up a little bit because I'm struggling a little bit to breathe. And that's what happens with an air conditioner. So if these coils get dirty and they get oily and they get a lot of debris in it, you're going to waste electricity because it's harder for it to breathe properly. So the nano coating doesn't allow this stuff to stick. So that helps maintenance, it helps energy, and all these technologies kind of combine to give us better efficiency. Now, if we look at the optimal end of this, and now you're seeing the number that I told you about at about 86% energy efficiency. Right now we're saving 86% energy. Now we have zero compressor. Our fans are half of what it was earlier at the higher temperatures. And now we're pretty much in heat pipe mode. And so what this air conditioner does, if you're an engineer, you'll appreciate the fact that it's got a PID controller on it. But the controller then learns, it kind of evaluates, and it looks at, okay, I want to speed control both systems, and I want to maximize energy efficiency. So I'll use my heat pipe as much as possible, and I'll only engage the compressor when I have to. All right. So again, these combined technologies nobody else has right now. This is just only a Rittal thing, and we've patented it. So that's the good stuff here. So the heat pipe, I'm not going to, get too much in the weeds on this, but basically it's another copper tube, right? That's vertical. It's full of refrigerant. So 134A. We don't use Freon, never have used Freon in the entire time that I've been here. And so what happens is the Freon absorbs, the refrigerant absorbs the heat. Okay. And when it does that, it turns the liquid to a gas. And so the gas rises, and then it gets up into the compressor circuit and that fan that's running up there. And then the fan blows across it. It expels the heat, right? So the refrigerant gives off the heat. And as it does that, it changes phases from a gas to a liquid. And then it wicks along the outside, goes back into the bottom, and you just rinse and repeat, right? It just keeps doing the same thing. And guess what? There's no mechanical energy in this. This is where you're maximizing your heat efficient or your energy efficiency. The only thing that might be running at some variable speed is that condenser fan at the top, right? I'm sorry, the evaporator fan. So that's kind of how the heat pipe works. Go on YouTube, look up stuff about heat pipe. It is the coolest technology. Again, we didn't invent it, but we're the only guys using it in AC units right now, and combine it with compressor-based cooling. This one, again, is just kind of what we call hybrid operation. Now the controller is throttling both sides to maximize cooling performance and then also minimize your waste. All right, so there we go again. There's our 3 modes of operation. This slide, just look at the SEER ratings. So we talked about energy efficiency. Energy EER assumes a 95-degree ambient constant. Well, unless you probably in San Diego or, you're won't have constant temperatures, right? So like I mentioned the other day, we got snow on one day. It's, you're mowing the grass the next in Ohio. So it's all over the place. When you add in the seasonal energy efficiency, then you're looking at something that's not a constant. You're looking at a variable based on climate. And so then that's going to fluctuate. And so here we're saying that the most money we're saving, we want this bar to be pegged out, right? So you're looking at heat pipe operation, you're saving the most money. Compressor, it drops off a little bit. This guy mentioned that's the energy vampire. And then we're doing our best here to run some mix of that and throttle both sides to maximize what we're doing. We've talked about that some. But the cool thing is this is just a label on the air conditioner itself. And so you can see on that label on the air conditioner what the energy efficiency ratios are. You can scan the QR code. That'll take you to a website that you can plug in some numbers and actually see how this will perform in your factory. There's another QR code that gives you things like all the technical data on the air conditioner, including spare parts. So how cool is that? I'm in the field, there's something going on, I want to check, a service update, or I want to look to order a part, I can do it on my phone with these Rittal air conditioners. Most air conditioners have, they heat rises, right? I mean, the temperature rises in the cabinet, and then the compressor comes on and it cools down. All right, compressor goes off, heats up again, compressor comes on, goes off. So you have that pattern, right? So you're looking here at this swing, and this swing in the white represents a 5-degree shift, right? 5 degrees Celsius shift. So maybe it comes on at 35C, which is 95. Cooling, goes off at 90, starts to heat up again, reaches 95. Now, why 95 degrees Fahrenheit? Rittal sets all its climate control that has a set point out the door at 95. Why? The sweet spot for electronics is 90 to 104 degrees Fahrenheit, 90 to 104. There's no reason to have something running in the 70s, right? Some people think, hey, the cooler, the better. Not really true. You can do more damage than good at that temperature. So 95 is kind of the sweet spot between cooling effectiveness, condensation management, lifetime of the components, right? But you have the swing, and sometimes that could bring in thermal stress and things into the controls, maybe if you've got some really sensitive electronics in there. So notice what the magenta line does, the pink line, if you will. It starts to learn, it starts out in that pattern. All of a sudden it says, hey, I don't need to be swinging like that. I can just, getting kind of crazy with up and down and off and on. And it tightens everything up. And it goes from a 5-degree swing, which would be about 9 degrees Fahrenheit, into 0.2. So by dialing it in, it maintains a very constant temperature that saves money, right? Electricity. And that it also is much easier on the controls because it's more of a consistent environment. So this is the really cool stuff that this air conditioner does. On this slide, we mentioned the cutout. And if you look in the lower right corner down here, we've got basically 2 form factors, if you will, of this Bluey Plus air conditioner. The smallest one is a 1.6 kW version. And I want to say those dimensions are 400 wide by 900 in the height. And then if you go to every size above that, regardless of capacity, you're at 450 wide millimeters, 450 wide by 1600 tall. So it's one cutout regardless, because what it does then, as you increase capacity, it varies by the depth of the air conditioner. Well, depth doesn't affect your cutout in height or width. So that is one of the things people were asking for, is make, kind of standardize a cutout for me. And you can also see here that this air conditioner can be mounted on the outside like every other unit in the world can. You can actually mid-mount ours, or you can fully internally mount everything but the largest size. It's just too much air conditioner hanging on to the inside to do that. But this gives you a very nice clean look. And sometimes if you're shipping over water or ocean or container, you're charged by cubic feet or, volume measurement. So if I can kind of tuck some of that in and reduce my footprint, I'm saving a lot of money. Just things to consider. When we talked about moving it around, in the square right here is a handle, an aluminum handle that's built into the AC unit. So instead of going to find a forklift and a 2x4 and a buddy and all this other kind of craziness, you still need a buddy for this unless you're, a lot of Wheaties in the morning, but grab that air conditioner and by the handle and just chip it into the bottom. And then when you tip it up, literally these clips engage into the cutout, and then it allows you hands-free to walk around to the other side and put your hardware on to permanently put this thing into the door or the sidewall or wherever you're going to mount it. So just the integrated handle makes it really nice and easy. Another thing that was requested of us to do. This is just the clips. Multi-voltage, I love this part of it. Basically, it's saying that no matter where you install this thing, you plug it in, it runs. How does that happen? Well, it takes all the AC current coming in, changes it. So it's got an inverter, changes it over to DC for all the controls that are inside. Everything runs on DC on this. And so your true multi-voltage from the 1.5 or 6 version, the 2 and the 2.5 kW versions, doesn't matter if it's 110 single phase clear up to 480 3-phase, you plug it in, it runs. How cool is that? If you're a distributor, if you're somebody that's stocking these, you no longer have to stock by capacity. Let's say I have a 2 kW 2000 watt version. Well, in the past, and with anybody else, right, you're stocking by my capacity, and then I need, okay, a 110 single phase, I need a 480 3-phase, and I need maybe, you know, a 230 version. Well, what's that just done? It's exploded your inventory. So you can drastically reduce that by having a multi-voltage air conditioner. And then it's the two largest ones, the 4 and the 6 kW versions that get you well over 20,000 BTU. That are 3-phase, but they're still within 380 to 480 voltage. So this again, and imagine if you're an OEM or selling to a machine builder and they don't know where, I mean, they may or may not know where their product goes. Now they really don't need to worry about what's going to have to happen out the other end with transformers or anything to an air conditioner because it's going to run. This is just showing the interface. We're getting short on time, so I'm going to kind of move through here, but this is just showing the interface. So it's a very clean, intuitive kind of interface. It shows me temperatures, and you can set the cooling based on either the return temperature to the unit or from the intake temperature that would be at the top. You can even do a corded external sensor to put it at a hot spot, and then you can generate cooling off of that. Any alarm condition is very obvious. Because it's red flashing in English, you know, that tells you the door is open, or they've got about 21 different languages now you can do this. And that's great if you're right there at the unit. Or what if I put a light? And so in an alarm condition, it goes to a light. Well, I still have to be on the floor to see that. So the other issue is what happens if I'm remote? You know, if I'm not at the site, can I still be informed that there's an issue? And the answer is yes, with the IoT interface that we'll talk about real quickly. So good stuff. I mentioned this before. If you've got an Android-based phone, you can download an app, but don't worry because it's secure. There's a code that you've got to enter. Then anybody can change the code once they do that on site, so that you know, nobody can get in and mess with your air conditioner. But be able to do that by phone is very cool. You can do it by laptop. You can do it by the IoT interface today. We talked about nano coatings. We talked about, you know, choice of filters is important. And we're not really going to go into that much right now because we've got disposable filters, we've got metal filters, and it really depends on the environment that they're going into, which one you should choose. Worst case, the nano coating does a phenomenal job. And in some environments, if it's not horrible, may not even need filters because of the capabilities of the nano coatings. So this is what's helping your maintenance costs as well. This one just shows the two different sizes kind of side by side. Okay, these are NEMA 12. We've also got some 3R versions and 4 versions, but you know, these right now are kind of what we've been talking about just right here, what you're going to be doing on the factory floor, indoor NEMA 12 kind of stuff. So IoT interface, as I'm trying to wind down here, this is remote monitoring and control of not only our air conditioner called Blue E Plus, but we have a other generation series that we're running in parallel. That's an older model, but still it's a great air conditioner called Blue E air conditioner. And there's probably tens of thousands of them already in the field. And so we've got an adapter that allows us now to go out to those customers and say, hey, guess what, guys, when we sold you that back in the day, we didn't have remote monitoring capability. When we do today, and we can actually have this little device, is really you see it right there in the middle of your screen, not much larger than your hand, the palm of your hand. And you've got, this thing gets an IP address, and now I can check it from anywhere in the world. And no matter where I am, I'm getting emails and I'm getting stuff to my phone that tells me if there's an issue or a problem at all. I can also engage up to 34 other sensors. I'm sorry, I don't know where that number came from. 32 other sensors. Things like, well, temperature, humidity, airflow, water, vandalism, door open. So access, right? I can actually tell when somebody has opened my enclosure door for security. So you can see that list right there of sensors that we can bring in under this, which again, under one IP address. This gives you a list of some of the protocols, so you can look at that quickly. And remember what Jeff mentioned, if I am going a little too fast toward the end of here to respect your time, you can always look at the recording and pick these up. And common question that comes up is, can I tie this into a PLC? Of course, the answer is yes. It's a little DIN rail mounted device, or it can sit on the back of the air conditioner. And it's initially set up so that one IoT interface can monitor and manage 2 air conditioners and 32 sensors under just one IP address again. And so it's very, very powerful. If I'm just using it, another thing that's kind of cool is power over Ethernet. If I'm just using this IoT interface or the module to monitor one air conditioner, you don't need any more power to the unit. You just plug it into the air conditioner in the back. There's an RJ45 hookup. I just take a Ethernet cable, go from my IoT interface to the air conditioner. I receive power and communication from the air conditioner to that unit. Pretty neat stuff. Here again, kind of talks about how I can wire it into browsers, PLCs, maybe management systems within a system. It kind of gets a little heavier right there, but it's important to know that it can do this, and it's not some kind of proprietary language or protocol that it's only, for Rittal. This is open source that you can see here that easily communicates across other systems. Our climate control product manager, Mark Poggency. Mark is out of our Schaumburg office. And so you can take his email right there if you'd like any kind of questions that may go his way. You can certainly get a hold of me or anybody there at Crescent. But let me think if I've got anything else here. So I think that's what I have to show you right now. And I think we'll go ahead and open it up for questions, Jeff. And if anybody kind of wants me to show the IoT interface, I can kind of do that as well. But let's see what kind of questions we have.
Yeah, no, we do have some questions. And again, folks, if you haven't submitted your comment or question yet, you can do so using the chat or the Q&A feature. But yeah, we did get a question come in about the IoT interface. Does that come standard with all units for the Blue E+?
Okay, so good question. When you get the IoT interface, you get the device itself, you get an Ethernet cable, you get a little DIN rail that has multiple positions to mount it on there. And then all you really have to do is plug that in. So the bracket to attach it to the air conditioner comes in the box. And then you just plug that into the air conditioner and you've got your your monitoring and communication. If you want to tie it back into your network, then in order for you to get remote access, remote monitoring and communication, then you'll need to tie that into your network under an IP address. And so we can pick it up 2 ways. You could have your IT folks go out there and assign a static IP address to it, and the instruction manual tells you how to do that. Or if you have what's called dynamic host protocol, you plug it in, it just picks up an IP address on your network and you don't even have to do anything. And then there's a way that you go to the air conditioner and kind of toggle through a screen and it tells you exactly what that IP address is.
Fantastic. But yeah, the IoT interface has spurned gotten people to ratchet up the Q&A. So we got them coming through right now. So staying along those lines, any special software required, Steve, to configure the IoT interface?
No, everything's on board, right? Everything's on board. And you literally, the cool thing is literally when you plug it in and it picks that up, you can open up your browser. Okay, so I don't know if you guys can see me right now. Your screen sharing is paused. Let me show this if you don't mind.
Yep, go right ahead.
So here's all I did was open up Chrome and I went to this IP address. You guys should be seeing this, I think. Are you? Resume share. I got to do that. Why? Anyway, let me answer the question so I'm not delaying, but nothing else is needed, right? The cool thing about this is it's almost plug and play. When you plug something new into the IoT interface, it automatically detects what that is. So if I plug in a access sensor, so say I've got a door sensor, and I plug that in, when I go to the browser and open it up, it's going to say access sensor. Now you can go in and name it anything that you want. You can call it maintenance cabinet 4, you can call it control cabinet on line 2, whatever you want to call it. You can name all this stuff so it's very intuitive to you. Mm-hmm.
Sure.
So you can do that, but nothing else is needed. Now, if I want to do a Blue E air conditioner, the last generation air conditioner that's still out there, there's an adapter. And so there's an adapter that you get. So you go from the IoT interface to the adapter to the air conditioner. And now you've got, what's kind of cool about that is since that generation of air conditioner, you can do what we call master slave or network those, up to 10 of them. So I plug in that sensor, and it also shows me that I could potentially monitor up to 9 or 10 other air conditioners off that one sensor. So it's really neat how expansive this can get. But certainly I think temperature monitoring and even power, it'll send you, there's a way to monitor the power if the power goes out. And then somebody asked me a question one time that says, hey, is there a way that if my air conditioner fails, you can start an internal fan? Absolutely. And I've actually got mine set up out there to be able to demo that so that I can change what's happening with the air conditioner and it switches over to an internal fan to try to circulate the air. So those are just kind of, let's say, redundant or backed up systems. It's kind of neat.
Outstanding. One more IoT interface question. What information what information is provided from the IoT interface, such as does it provide current temps, set, high, low, any alarms or maintenance info, anything you could talk about in terms of what's included?
Yeah, great question. And so let me answer this and then I'll try to see if I can pull it up. So you're going to get run times on your computer. You're going to get energy efficiency numbers. You're going to get high temperatures, low temperatures. You can set those thresholds. So say that you want an alarm at 100 degrees Fahrenheit, but you want to know about that when it hits 95. So you can set thresholds and then you can set alarms on the high side, the low side. You can set, you can create your own charts. So I could do something on a chart that says, I want to, in real time, monitor temperature or temperature and humidity. There's so many parameters that you can monitor, or up to these 32 sensors. And the cool thing is when you have that browser open and you can create up to about 16 different charts and overlay the information. Say you want to go, I really want to know what kind of energy savings I have. So maybe you overlay the sensor of the compressor usage with power, or maybe you do compressor runtime versus your energy efficiency. And so now you're actually knowing what you're getting out of that unit. So there's you can custom design what charts, and then you can take a chart and it's called docking or undocking. You can undock that chart and pull it off to a different monitor and monitor that and watch it in real time and not have to have the whole interface up.
Fantastic.
And I've got mine set up so that all it does is every weekend, instead of me going in and just logging in and checking to see if everything's okay, I've got it set up to say every Saturday, just send me an email that says there's no alarms. And so every Saturday I get an email that says no active alarms, and it goes through everything that's on there. And it's a huge list because all the sensors that are on the air conditioner and anything else that I have tied up to it.
That is really impressive, Steve. Last question.
Yep.
This attendee said, hey, great information, Steve. Is there a video available to watch the unit in action and discuss any additional functions that you may have covered?
There are videos out there. There's a lot of marketing material that would be, one thing you could probably do would be to go to, like if you were at YouTube. So certainly on our website, there's videos you can watch, but I personally, I kind of like the format on YouTube because I can control the screen size a lot better. But just put in Rittal North America. Like if you search for that, and it'll come up on our channel, and then you can just search by like Bluey Plus, and you'll see a lot of stuff. If you just go to Rittal, you'll get every language and country in the world, right? So you want to search through that a little bit, sort through it. But if you just go to Rittal North America, a lot of videos on that. There's stuff on Bluey as well as Bluey Plus, and they've got a lot of good videos on the capabilities and some of the workings, and even the IoT interface. I'm just going to show you some of the stuff that I might not have been able to bring up right here. They do a good job with that.
No, that's perfect. And just a reminder as well for the folks that are listening, some of the content Crescent's produce in conjunction with Rittal, from videos to blog content. We've got lots of information and plenty of helpful sales reps and branch managers and district managers that are more than happy to discuss, for the locations where we're franchised, more than happy to discuss this in more detail with you. But Steve, that looks like the extent of the questions that came through. So
Okay.
why don't I turn it back over to you? Let me just go through
Okay.
one last time to make sure we haven't missed any, and I don't see any final questions coming through the chat or the Q&A. So I'll just turn it over to you for some final thoughts before we adjourn.
I think you seeing the screen right now?
Yes.
Just found a quick way to cheat that out. Two things as I'm doing this. Two things as I'm doing this is warranty, right? So air conditioners have a 24-month after the date of manufacture warranty. If they go to our website and register that product when they purchase it, if they can extend that warranty by 6 months. And then there's also things we can do that potentially could extend a warranty out to 5 years. So our service department would be able to handle those types of questions and concerns, but it's a pretty powerful warranty program that we have. And again, that's going to be for air conditioners, it's going to be for chillers, and it's going to be for a big liquid cooling product that we have on our IT side. But those are, again, they can get 30 months if they just go on our website and register that product. And so energy audits, I know Crescent, I think, has done a lot in the past with different energy audits, and some of our folks as well. And really, we're not talking about opening cabinets. We're talking about walking out with FLIR devices, maybe looking at a cabinet that somebody suspects an issue. What we also really want to do is just look from a best practices standpoint. You're looking at a cabinet, does this air conditioner over here, regardless of whose it is this air conditioner, what's the code that it's flashing? What's the issue there? Or, you're seeing things that shouldn't be, like fans and air conditioners on the same cabinet, or water that's pooled up on the bottom. There's all that kind of things that could be glaring to say, we've got an issue here. Let's talk about how we can help you with this. And so those are an interesting way just to get out and help a customer or partner up to walk out and look at something on the plant floor and just kind of see what's glaring to help people save money and alleviate any kind of downtime issues. So I just kind of wanted to mention those two things. Here is my interface at the left. These are all the components I have attached. All right. And then what I can do, for example, if I want to go to a temperature and humidity sensor, I can look in this format, which is really cool because I can see my temperature, I can see my percent humidity, and now I've got my different warning tracks and levels. And so you can see I go red, I go yellow or orange. I can adjust this very easily in this interface. And if you don't want it, you can go back to this way, and then you can open it up and see everything, a little more text, right? So it gives me the same kinds of things. And some of these I can change from here, but certainly monitoring. And then I was talking about charts, right? So I can look here at my ambient temperature. And so this is something that is showing the ambient temperature that I have set up around my air conditioner. This is just one chart that I built. Another one, and this is showing a flat line because I set this one up so that if I turn the air conditioner off remotely and have the fan kick on, this would spike because this is a power unit, which powers the fans. And so I have it set up to relay that. I can do temperature and humidity, and so they'll overlay. This next one is kind of interesting because, oh, where'd it go? Let me see if I can go backwards. Anyway, I don't want to take too much out of your time, but this one I have that sometimes if you capture it right, it shows the peaks when a Blue E unit will come on because it has eco mode. And in eco mode, it's on for like 30 seconds or so and then shuts off for 10 minutes when it's cool enough. And so it's saving money. And so usually I have the screen set up and it looks at those spikes and it sees when that occurs. But if I go back up to this one and I do that undock feature I was telling you about, then I can pull this off and I can just move this to some other screen if I'm, interested in watching this in real time and not have to have anything else up. And I can actually set up my phone to receive these same types of shots. So really, really cool stuff. I can simulate alarms to make sure that the system's working right. And again, in the event of an alarm condition, and if I can just have 30 more seconds, I want to show you. So I'm going to demo this in real time for you so you can see what this looks like.
So once again, while we're waiting for Steve, we are recording this. So if you happen to be watching on the archive version of this this session, again, would still love to have you guys send us your comments or questions, but send it back to Steve.
All righty. So what you can see here is this turned red. So this tells me exactly where the issue is, the alarm condition is. And all I did was I moved a sensor that simulates the door being opened on my cabinet. And so you can see that it's flashing. This is red. And also I get something down here that tells me that there's an alarm condition. And then I will have gotten an email that came to my phone because it goes to email, right? And so it's going to, right there it is. I don't know if you can see this, but right there, it's going to give me the information from the system that came to my, and I can be in Houston, I can be in Germany, doesn't matter. I just got this email that told me that somebody's trying to get in my cabinet. So that's what an alarm condition looks like. And, to show you guys, this isn't some unicorn product that we talk about. Like, well, it should work this way, or it might work. No, this stuff is good. It works great. And that's, it's pretty powerful. So I like it a lot. I like to demo it. I like when it works right, so the only thing about live demos is you never know what's going to happen, but this is a reliable product. I like it. Well, so that's all Steve. I got, Jeff.
No, this is fantastic. And again, appreciate those of you joining us live. And again, this is being recorded. So we'll have some individuals, again, those of you that happen to be tuning in on the archive as well, between the resources on the Rittal side, and of course, all the resources at Crescent, at your local branch. Happy to answer any additional questions you might have, and be sure to check out the special content that Crescent on our social media. Hopefully you've seen it already. Some of the blogs, some of we'll get the archive webcast out, as well as the other all the info you'll need to know about this great product. So, on behalf of Steve and the Rittal team, I'm Jeff Lampe, and on behalf of our Crescent team, thanks for joining us, and look forward to having a dialogue with you soon about what this product can do to support you and your customers.
Thanks. Appreciate it.
Thanks, everybody. Mm-hmm.